should have all of your guided notes handouts, your A, B, and C from this chapter. So all of these terms come from those handouts directly. If you don't have them, you may want to find a friend who has them, because I don't make extra copies of those. So you need to know the definitions of these terms. They come directly from your handouts. I'm not trying to trick you. I just need you to know them. The next part is being able to give examples. So this is also in your handout. You need to know the difference between vectors and scalars. You need to know your notation so that you can recognize it. You did this on a quiz, Cartesian, cardinal, and map directions. You should be able to sketch angles and know how to calculate reference angles. Calculate your sides and angles from SOHCAHTOA, right angle trigonometry. Your vector addition, which is what we just did on this last one, and vector word problems. All right? And so what happens in the next few pages are examples of all those things. The first thing we did was sketching angles based on what they gave you, and then giving the reference angle. So reference angle is closest to which axis? The x-axis, right? So you're first going to sketch the angle, and then you're going to figure out how close it is to your x-axis. Let's look at a couple of ways they can give it to you. When you just see this, what type of graphing should you be doing? Cartesian, which means we start at the positive x-axis and we go counterclockwise 190 degrees. So you should start at the x-axis, counterclockwise 190 degrees. So that would be the correct sketching of that particular vector. Then I need to be able to calculate my reference angle. How close am I to my closest x-axis if I'm at 190 degrees? I am 10 degrees away from my closest x-axis. All right, so there's two other ways they can give it to us. The second way that they can give it to us is either like this with that capital T, or the word bearing or heading, actually. They could use that as well. What type of movement do I do when I have a true north or a bearing? Where do I start? How do I move? So I'm going to start due north, and I'm going to go clockwise 140 degrees, which means I'm going to start here, I'm going to go here and around to there and drop it at 140. So then my reference angle is closest to the x-axis. What is my reference angle here? 50 degrees. I went 90, then another 50 to get to 140. The last way that you can have this is in directions north of east, west of south. Those are strictly going to be whatever they tell you. So remember, the first one is telling you your movement. The second one is telling you from where. So if it is north of east, I'm going to start east and go north. If it is west of south, then that means I'm going to start at south and go west and draw that. Again, sometimes when they hand it to you, they give you your reference angle. Sometimes when they hand it to you, they don't, because you will not be given what is closest to the x-axis. Again, you're going to sketch it and then reference angles closest to the x-axis. So for number 4, 80 degrees north of east. Remember on this, we're talking north, south, east, and west, right? So if I want north of east, I'm going to do, this is going to be the 80 degrees. So in that case, they handed me my reference angle in the instructions. First, let's look at the instructions. Use the given vectors to sketch the addition problems, then calculate the magnitude to the nearest tenth and direction to the nearest degree. If it were in standard position on the Cartesian plane, meaning I want your answers in standard Cartesian, right? Starting at X and going counterclockwise. So I'm going to do number 3 for y'all. I typically go ahead and write my movement for each of my vectors, okay? So for example, if I am at A, I'm going to write my movement in X, Y coordinates. I start at this end and go to the other end, the arrow. So I move left 1, 2, 3 and down 1, 2, 3 to get from start to finish of this vector. If I were writing that in X, Y, that's going to be a -3X movement, a -3Y movement. And I'm going to do that for every one of my vectors. If I am looking at B, I'm going to go to the right 4. I don't go up or down. So I'm going to write my xy. So I'm going to do this all the way across for all of these. What that's going to do is that's going to help me sketch it, and that's going to help me calculate at the very end. So I already have that in place when I start doing all of these. Make sure that you double check your direction, because positives and negatives matter, all right? Left is negative, right is positive. Down is negative, up is positive. So you have to think about that when you're writing your X's and Y's, all right? So I'm going to do 3 so that you'll have some to do, all right? So using that, we're going to go to 3. 3 wants me to take D, add B, and subtract A, all right? So the first thing I'm going to do is sketch it, then I'll worry about my adding and subtracting stuff. So if I'm going to sketch these, I'm going to draw my D. Well, D is going to start at a point, and it doesn't matter where you start wherever you want to. You want to think about what your movement is so that you have room for it. But if I'm starting here, my D went right 5 and up 2. So this is my D movement right there. That's my D. I'm going to add to it my B movement. B doesn't go up or down, it just goes right 4. So I'm going to go right 4. That is my B movement. Now negative A means that it goes the exact opposite for both movements. So look back at your A went -3, -3. A negative A is going to go +3, +3. So now I need to go right 3 and up 3 to move negative A. All right, that is my negative A. And so that is my movement. What I'm trying to calculate with magnitude and direction is my resultant. So if I were to start at D and go directly to the end of A without making all those crazy turns, what would that look like? And so that's the resultant that I'm trying to calculate here. So I'm going to draw this little dashed guy to indicate that is my resultant, all right? As far as your X and Y resultant, there's a couple ways to think about this. You could just count, right? So I could literally start here and I could count how far it took if I just moved right and how far I would move up. I could count. You're going to get the same answer. You can add and subtract them. I can go back and I can list those things that I did at the top. I have D, that's 5, 2, plus B, that's 4, 0, minus A, that's -3, -3. Now, what I would recommend for subtraction is adding the opposite, just like you would do in algebra. So I would recommend adding the opposite of both of these. It would probably be easier when you're adding and subtracting these, okay? Then you're just going to go across. 5 plus 4 plus 3, that's 12. 2 plus 0 plus 3, that's 5. Okay? If you counted, you would have counted right 12 and up 5. Okay? Now magnitude. What is my formula for magnitude? So for magnitude, which is what it's asking for one of these, my magnitude is the square root of x squared plus y squared. So that's exactly what I'm going to do. It told me to round to the nearest tenth. So to calculate the magnitude of this resultant, it's going to be the square root of 12 squared plus 5 squared. All right. Now remember, if one was negative, you can actually ignore it because in your calculator, if you square a negative, it's positive, right? So you don't have to worry about putting your negatives in when you're calculating magnitude. It's going to come into play when we talk about direction. But for magnitude, the square is going to be positive always. So what do you get when you calculate that? Rounds away from a decimal place. So 13 to one decimal place looks like that, but that's fine, 13. Direction. All right, how do we calculate direction? In our word problems, we've been doing this. How do we calculate it? Y over x. So the inverse tangent of my y over my x is going to give me direction. All right, y over my x is going to give me direction. Again, you do not have to worry about positives and negatives because your calculator is always going to give you what angle. Your calculator is always going to give you your reference angle. You have to figure out what quadrant you would be in with these X's and Y's. The other way to think about it is, if I were to draw an XY axis right here, what quadrant would I be in? First quadrant. If I look at my 12-5, positive, positive, first quadrant, right? So in the first quadrant, your calculator is going to give you your reference angle, correct? Does that make sense? In the second quadrant, you're going to have to subtract from 180. In the third quadrant, you're going to have to add to 180, right? Do you remember those shortcuts? So we are talking about Cartesian plane movement here when we find our angle. In this case, it gives us exactly what we need. In your calculators, you're going to use your inverse tangent, which is your shift tangent key. You're going to use 5 divided by 12. Close those parentheses. This wants you to round it to the nearest degree. Nearest degree. What is your whole degree here? 23 degrees. Calculated is you've calculated your direct movement length, and now you've calculated your angular movement from a starting point here. Angular movement, you went up 23 degrees. This is just review. This is how we moved to our word problems. This is why our word problems work, but this is the review piece of it. So remember, on SOHCAHTOA, we have sine. What is sine? What does that O and H stand for? Opposite and hypotenuse. Ka, what does the AH stand for? Adjacent and hypotenuse. And we have tangent, TOA. What does the O and A stand for? Opposite over adjacent. All right, SOHCAHTOA, sine, cosine, tangent. So it is always in relative to the angle that you're talking about. So the first thing you want to do when you come up to a problem like number 1 is you want to figure out where your angle is. My angle is right here. That's where they have that theta. If I were to stand in the corner of that angle and walk all the way across this angle, I would get to my opposite side. Stand in the angle, walk across, you get to your opposite side. If I were to stand in the right angle and walk across, which side do I get to? Hypotenuse. It's also my longest side. So then that leftover guy, which is actually part of your angle, is your adjacent side. Always label your angles. Always label your sides based on that angle, based on the reference of that angle, okay? Then I'm going to look at what trig function they're talking about. They are asking me for the tangent. The tangent. Which two sides do the tangents deal with? Look at your shortcuts. It's opposite and adjacent. I have my opposite. I don't have my adjacent. There is one other theorem that we can use when we need one side of a right triangle. What is that theorem? A squared plus B squared equals C squared. Pythagorean theorem, all right? C is always your hypotenuse. C is always your hypotenuse. The other two don't matter because you're adding. Hypotenuse matters. He has to go where that C goes in that formula. So to solve for this, I have to have that adjacent side. I must use that to do it. So I'm going to say A squared plus B squared equals C squared. In right angle trigonometry, it's always positive. So what A do I get? A squared plus 64 equals 100. Subtract your 64, take the square root. What is A? A is 6. I now have the sides that I need. All right, I have the sides that I need. All I have to do when they are asking for the trig function is give the fraction. I am going to list the tangent is going to be the opposite side, 8, over the adjacent side. Do you think I'm going to leave it that way? What am I going to do to him? Reduce. What is it? 4 over 3. That is the tangent. Tangent is just the ratio between the sides. Ratio between the sides. That's all it is. So what's nice about finding the angle here is that I don't have to use Pythagorean theorem. I can just figure out which sides I have. So I'm going to choose a different one because this ends up being a tangent as well. So let's look at number 9. Let's look at number 9 here. We'll just scoot this up. Number 9, I am going to label this angle, this triangle, according to this angle. So if I stand in 64 and walk across, that is my opposite side. across from the right angle is my hypotenuse, which means this x is my adjacent side. So the two sides that they have noted on this particular figure is the adjacent side and the hypotenuse side. Which of my trig functions dealt with adjacent and hypotenuse? Remember your SOHCAHTOA. Cosine. So the cosine of my angle, which they gave me, 64 degrees, should equal my adjacent side, x, over my hypotenuse. Now we just have a basic algebra function. How do I solve for this? What do I do to both sides? Multiply by 7. Multiply by 7, multiply by 7. All right? It says round to the nearest tenth. So you're going to say 7 times the cosine of 64 degrees in your calculators, and you're going to round to the nearest tenth. What do you get? 3.1 rounded to the nearest tenth. All this does is it combines the other two sections, all right? Combines the other two sections. When they say solve the triangle, they want the measurement of every single angle and every single side. Remember, the sides that I list here are opposite of that angle, all right? So if I have side A, it's going to be opposite of A. Side B is opposite B. Side C is opposite C. That's how I'm listing those, okay? They've given me my right triangle, so that means I automatically know that's 90 degrees. They've given me my B angle, which is 34 degrees. All angles in a triangle add up to 180. In a right triangle, my non-right angles add up to 90. So I can just subtract from 90 to get that third one. What is he? He is 56. Then I'm going to go ahead and fill out the sides that they've given me. They've given me side B, which is 6. So I need to solve for side A. I need to solve for side C. All right, let's look at A. I have angle A. That is 56 degrees. I need side A, and I have side B. According to angle A, what are side A and B? Is we're going to use tangent. Why? Because side A is opposite, side B is adjacent. So the tangent of that 56 degrees should equal my opposite side over my adjacent side. We're going to do the same thing there that we did before. What is it? Multiply both sides by? What do we get? 8.9. There are two ways to solve for C. How do I solve for C? There's two ways I could do it. I could use Pythagorean theorem, or I could use a trig function, right? It's up to you. Either way, what do you get? Solve for side C. You should get that. Double check and make sure you do. Make sure you do. You can either use a trig function like we just did for A, or you can use Pythagorean theorem. A rescue helicopter is attempting to lift a stranded hiker from a mountainside. The helicopter applies an upward force of 2,000 newtons at an angle of 60 degrees from the horizontal, while the wind pushes against the rescue operation with a horizontal force of 500 newtons from the east. Determine the magnitude and direction of the resultant force on the hiker. Okay? So, keywords here. So remember, what we're going to do here is we're going to do a sketch, potentially. Some of you may not need to do a sketch, but some of you may want to do a sketch. I would need a sketch. We're going to read. So, the first movement they talk about is in that second line there. The helicopter applies an upward force, 200 newtons. That is my magnitude. 60 degrees from the horizontal is my direction. All right. Remember, from the horizontal is going to be from the east, right? Think about up, above the horizontal, below the horizontal. Okay. So we're going to draw a 60-degree angle above the horizontal over here. So we have a 60-degree angle. And they were nice, and they actually gave us that reference angle that we need to use. Okay. So there is a formula here. How do we calculate our X movement and our Y movement when we have been given the magnitude and the direction? What's the rule there? So I'm going to break this down into an XY movement. In this particular case, for this one, how do I know whether I'm doing positive or negative on those X's and Y's? How do I know that? First quadrant. What are my X's and Y's? both positive, right? So in your calculator, when you put those in, it's going to always use reference angle. It's going to always give you positive. You make the decision as to whether you apply a positive or negative to that XY based on where you are, okay? So what is your XY movement for this? We're going to say, well, 2,000, that's my magnitude, times the cosine of that 60, that's my X. 2,000 times my sine of 60, that's my Y. What do I get there? Here's my Y, right? So 500 is my X, 1,732 is my Y. Sorry, I went ahead and calculated it. Sorry. I went ahead and added it to the next part. The next part's negative 500. I'm moving ahead in my brain. There we go. Cosine of 60 is 1/2. So, so 1,017.32. They gave me a second movement. Something else is affecting this. The second thing that's affecting this movement is a horizontal force. This is the wind, 500 newtons. This is a key word, from the east. From the east. So it is moving to the west, all right? From the east means that direction it is coming from. So remember, from the east is just like us negating that A when we subtracted. Everything goes the opposite. So in this case, from the east, I don't have an up and down movement. It's going this direction. And I don't even have to multiply it by an angle. I know it went left and did not go up and down. So how do I note that with an X and Y? Negative 500, and I did not go up or down. I don't even have to worry about my cosine and sine here, right? I don't even have to worry about cosine and sine. When it is east, west, north, or south, you don't have to worry about it. If it is an angular movement, you do, all right? Now, the last piece of this is just like we did calculating our resultant vector. We are just simply going to add our two X's and Y's. If it will let me move all of that, that would be great. All right. So we're going to add our X's and Y's to get our resultant. What happens when we add our X's? What do we get? 500. What about our Y's? 1, 7, 3, 2. Positive, positive. What quadrant am I in here? I am in the first quadrant. So when I calculate this, it is going to give me my reference angle, right? I need to calculate magnitude and direction. We just did this when we sketched it. How do I calculate magnitude? Square root of my X squared plus my Y squared. What do you get when you do that? All right, so I'm going to write down 1802. We'll talk about it in just 1 second. 1802 newtons. All right. How do I get direction? Inverse tangent of my Y over my X. What do I get there? 73.89 is what you get. All right. Couple things here. First of all, go back to your problem. How many significant digits do I have? 3. This one on purpose. So I need 3 significant digits. How many significant digits does 1,802 have? 4. So to get it to 3 significant digits, I technically am going to write this like here, and then I underline where my significant digits end. When it rounds out to where you have zeros, you have to tell me where it ends. This ends my significant digits, 1, 2, 3. Okay? Significant digits there. My angles. What do I need to do to get that to 3 significant digits for my angles? Round up. 73.9 degrees. However, 73.9 degrees, that's not how they gave me these directions. So how do I actually need to give those directions back? My resultant ends up here. It's right here. How would I write that using north, south, east, and west? You could say above the horizontal. You could say north of east, correct? Both of those are valid. They told me a horizontal. They told me from the east. So you could say 73 degrees above the horizontal. That's fine. Or you could say north of east. Either of those would be correct.